Okay, so good afternoon to all of you. Here we can start our today's lab with first of all I am going to explain you a theory behind your experiment. Then some work will be assigned to you. Okay, this work will be done by you in your book, and then you will implement your explained circuit on digital IC trainer kit. Okay, in this way we have divided our today's lab. So here, first of all, I have shared the screen. Is it visible? Okay, here I have opened your index. So generally, we start our experiment with the index. So here today we need to perform your sixth experiment. And title of sixth experiment is construction of encoder and decoder. Let me highlight it so you can easily read it. Construction of decoder and encoder. Okay, so first of all, I will explain the theory behind it. What you are doing. Okay. So first of all, the theory will be explained. Then I will explain how your lab manual will be prepared. Okay. So before start your actual theory, here one animation is given. Look at this animation carefully. And started by you, corner one. What is your observation in this animation? Next. Next to him. What is your observation? Yes, Afnan. Sorry? Gates are there, okay. Any other observation? Jaideep? Okay, so here we can observe one thing. Whenever input is 0, 0, one line of the output is high. You can see. Okay. Next, suppose, and rest of the lines are low, output line. Next, suppose I am going to press or I am going to set 0, 1. Now, what is our observation? One line is high, rest of the lines are low. They are producing low voltage. Only one line is generating high voltage. Okay, but it depends on input. Which line will generate high voltage depends on input. Let's say again I'm going to change the input in place of 0, 1. Over here I have pressed 1, 0. 1 input and 0 input. So one line is high, rest of the line generating low voltage. Let's say if I am pressing 1, 1, if I am giving 1, 1 as an input, higher AND gate output will be high. Rest of the AND gate is generating low voltage. So here I can say that it is one circuit which is having some number of input, some number of output. Only one output line will be high, depends on its input combination. Okay, so this kind of circuit is called decoder. So today you need to implement this circuit and you need to check a same thing using your implemented circuit. Okay, this animation is clear. So here we can start the description of decoder. So ready-made IC is available. IC name is 74138. 74 series means it is digital IC. 38 means a decoder which is having 3 input and 8 output. In this animation, how many input were there? 2 input. So 4 output. Decoder are available which is having n number of input and m number of output. Where what is the relationship between n and m? If 2 input, then 4 output. If 3 input, then 8 output. If 4 input, then 16 output. Okay, so output is equal to 2 raised to input. Output is equal to, output line is equal to 2 raised to input line. Okay, so this kind of circuit is called decoder. The same thing what we have studied by means of animation, it is described here. What is the definition? A decoder is a kind of circuit that accepts set of input, either 2, 3, 4, 5. Okay, set of input that represents binary number, and it will activate only one output line. But which output line will be activated? Depends on input. I hope now you can understand the definition of decoder. If directly we see the definition, then it's little bit confusing. But once you will learn this animation, then this definition is perfectly understood. Depends on input, one line will be activated. That is called decoder. So decoder block diagram, a decoder is a circuit which is having n number of input and it can generate m number of output, where m is equal to 2 raised to n. There is doubt in this block diagram definition. So here 2 cross 4, 3 cross 8, 4 cross 16, this kind of decoder are available. But today's lab, you need to implement 2 cross 4 decoder. So I am going to explain this 2 cross 4 decoder. Rest of the theory, many subtopics are given under decoder that will be covered in the theory portion. Okay, here just a laboratory purpose, we are going to cover 2 cross 4 decoder. Now again, if 2 cross 4, then 2 input, 4 output. Now over here, some devices are connected. Now can anyone tell me what can be the application of decoder? Where it can be used? Where decoder can be used? For it, a CD driver is available. A mechanical process is there. Over here, decoder will be used. Let's say if I am having total 4 devices. Okay, CD driver, keyboard, mouse, and hard disk, or any other device which is indicated by this green color or like this. 4 devices are there. Cables, physical wires are already connected, but still suppose you want any one device should be switched on at a time. Wires are already there. Wires are connected. They are not disconnected physically. But logically, they will not get any voltage. So they will not on. They will remain off. Although wires are connected. Okay. So whenever your application is such like that, many devices are connected together, but only one device should be on at a time. At that time, output of decoder will be connected to power supply of these devices. So can anyone tell me, if I want to own keyboard, which input combination should I give? Okay. Right now, A0 is LSB, A1 is MSB. So 1, 0. If I want to start this green color device, which combination should I give at the input? 1, 1. It depends on the number. See, D0 means 0, 0. D1 means 0, 1. D2, 1, 0. D3, 1, 1. Okay. So it depends on connection. We will see. See, in the animation, D0 was indicated at the bottom line. Depends on the internal connection. We will also see which kind of circuit is there inside this 2 cross 4 decoder. Okay. So only one of the input is activated. So after block diagram, what is our next step? What we need to do? Once block diagram is prepared, what is the next step? Truth table. Okay, so in truth table, A1 input, A0 input, D0, D1, D2, D3 are output. Whenever input 0, 0, D0 line should be activated. Rest of the line should be deactivated. D3 means input is 1, 1. D3 line should be activated. Rest of the line will be deactivated. Okay, now after truth table, what is the next step? After truth table, what is the next step? Boolean equation. How many equation can be made? Yes, Boolean equation, number of Boolean equation is equal to number of output. Total 4 output, D0, D1, D2 and D3. So 4 equation. D0 is A0 bar, A1 bar, D1, A1 bar, A0, D2. See, whenever you are going to learning it, it seems to be very easy, believe me. But whenever you will write your paper, at that time you will mistake by putting 1 to 0, 0 to 1. And at the end, everything will be wrong because truth table is wrong, then Boolean function wrong, circuit wrong. Ultimately, we will be getting 0 mark. So please be attentive. So is there any doubt in Boolean equation? Once Boolean equation is made, then we will design a circuit. So in this circuit, what is D0? A1 bar, A0 bar. So here inverter are taken. Inverter, this is A0 bar. And this is A1. Based on the equation, connections has been taken. So what is your role after completing all this theory? You will take your book and pen. You will write the truth table of decoder and you will draw this diagram without any help. Okay. So this is about the decoder. Fine. Don't take screenshot. You can't take any help. You need to do all this thing by your own self. Truth table and circuit. Okay, next circuit is encoder. So let me open first of all encoder. Now before starting the encoder, again one animation is there. I am going to put this animation link in the chat box so you can refer it. Many related animations are given. Okay. Now look at this video. Please observe it. I am going to ask some question. I have shared one video. Is it visible? Yes. Okay. Again, I will replay it. Every time output will be taken from input for every circuit. Whenever zeroth switch is pressed, Whenever, again I will replay, whenever zeroth switch is pressed, none of the LED glow, means 0, 0. Output is 0, 0. Please look at there. Now first switch is pressed, output is 0, 1. Next LED switch pressed, output is 1, 0. Whenever last switch is pressed, output is 1, 1. So this is called encoding. This process is called encoding. At the output, we can get a bit pattern. Okay, this is called encoder. So here we will see the theory behind it first of all. Encoder, which is having n number of input, n number of output, where m is equal to 2 raised to n. Remember this thing. Let's say I am having 2, or I can say that 4 input, then output will be 2. Okay. Now 4 cross 2 encoder. So 4 input, 2 output. Let's say 8 cross 3 encoder. So 8 input, 3 output. So you just need to remember number of input output for encoder and decoder. Don't be confused about it. Okay. Now what is happening? What I need to do, so encoder, it's a kind of circuit that will generate a coding as per the input. So there are 4 input. If this switch is on, we have seen from the animation, if this switch, over here switch will be connected. If Y0th switch will be on, then output will be 0, 0. When first switch will be on, this is the first switch. Output is, what is the equivalent binary of 1? 0, 1. That's why output will be 0, 1. Whenever this second switch is pressed, means it is 1. What is the equivalent output pattern of 2? It is 1, 0. Likewise 1, 1. So this is the truth table of encoder. It will give a coding pattern. Depends on the input. If 0th switch is pressed, then 0, 0. First switch is pressed, then 0, 1. Let's say your encoder is 8 cross 3. So what happened? 8 cross 3. 8 input, 3 output. 8 input, 3 output. Okay, so 0th switch is pressed in 8 cross 3. Yes, every time it will happen. Still similar to circuit will be there, mux and demux. Every time you will be confused about, I'm talking about in examination, input and output. You will write decoder in place of encoder, encoder in place of decoder. This is the thing happening every time. That's why what problem you will face, generally I discuss it. So 8 cross 3. So let's say 6th switch is pressed. 6th switch is pressed. What will be the output? 8 cross 3 encoder, 6th switch is pressed. What will be the output? 7th switch is pressed. What will be the output? 1, 1, 1. 8 cross 3. 8 input, 3 output. 0 to 7. If 0 pressed, then 0, 0, 0. First number pin is pressed, then 0, 0, 1. 7th number means 5, 7 is pressed, then 1, 1, 1. So in this manner, truth table will be happening. Now, once truth table is done, what is our next step? Boolean equation. So Boolean equation can be made. How many Boolean equation you will make, Paras? How many Boolean equation you will make? 2. Which is the Boolean equation of A1?
Y3, Y2, Y3 bar, Y2 bar, bar.
And for A0 means there are two 1. Huh? In A1 column, there are two 1.
Yes.
In previous case, we had only one 1 in decoder. Here per column, two 1. What is the equation? So you need to draw the K-map. Okay. First of all, can anyone tell me how many cells should I draw? Two cell. 8 cell. 4 input variable.
16.
16 cells should be drawn. See, ધ્યાન રાખો મારે કોઈને ઇન્સલ્ટ ન કરવી પડે. Be attentive. હજી કહું છું. I should draw 16 cell. Is there any doubt? Then here, if I am going to take, let's say, MSB here, Y3, Y2, Y1, Y0. So here 0, 0, 0, 1, 1, 1, and 1, 0. Horizontal number 0, 1, 3, 2, 4, 5, 7, 6, likewise. Okay. Now what you need to do? This table is right now prepared for A1. So here 0, 0, 0, 1 means they are talking about which cell? 0, 1, 3, 2. Okay, where I should put 0. Now 0, 0, 1, 0. Which cell should I select? 0, 0, 1, 0. Second combination. So 0, 0, 1, 0. It's 2. It's 2. So here 0. Then 0, 1, 0, 0. 0, 1, 0, 0 means 4. So fourth cell, what should I put? 1, 1, 0, 0, 0. What should I put at eighth cell? 1. Do you know how K-map should be prepared? Do you know how K-map should be prepared? So how I put this 0, 0, 1, 1 there? Can you explain it again? How it has been decided that this cell will have 0 value and fourth and eighth one cell will have 1 value? Sorry? What should I put in the rest of the cell? Generally, what happens in the truth table? All combinations are given. So we can put some cell will have 1, some cell will have 0. Here, 2 cell are having 0, 2 cell are having 1. What about rest of the cell? Yes, from here, what should I put rest of the cell? Whenever my input 0, 0, 0, 1, I am getting 0. Definite logic 0. Whenever my input 0, 0, 1, 0, definite output 0. Whenever my input 0, 1, 0, 0, definite output 1. Whenever my input 1, 0, 0, 0, definite output 1. What about other combinations? Suppose I am going to give 0, 0, 0, 0. Output 0 will be generated. We should not design this kind of circuit. We should design such a circuit. If I'm going to give this combination, then definite output will be generated. Other than this, a certain output will not be generated. So rest of the position I should consider don't care. Rest of the position I should consider. I'm not going to solve it out. I am going to give you to solve this equation. Is there any doubt in the KMF? And KMF is not given in this PPT. You need to solve it out. Is there any doubt in the KMF? Same way you will make KMF for A0. This KMF I have prepared for A1. Yes, what is there about to talk? Same way you will prepare a KMF for A0 and you need to solve the equation and then you will prepare one circuit. This is your task. So here, yes, but right now your equation will be in SOP. Whenever you will be asked particularly that solve this equation using POS, at that case you will write POS. Otherwise, every time you will consider SOP equation. So here, right now we should focus on one only, JD. We need to focus on one. Wherever one are there, we need to cover it. But in your exam is particularly, they will ask you that solve it using POS. Then you need to focus on zero. You need to think. We have covered one with don't care condition. We have covered this topic. You need to use this fundamental and you need to give me the equation. This is your responsibility to make the equation. Same way you will make a KMF for A0 equation and then final circuit. Okay, so here my explanation part is over. I would like to open your lab manual once so I can explain to you how your lab manual will be prepared. I have opened it, one Word document. Is it seen there? So this is for experiment 6. Okay? Decoder and encoder. Here apparatus means which logical circuit or IC that you are going to use. Name of it, digital IC trainer kit, wires. Okay. Then theory. You will write decoder, encoder, a brief about it. Then logic diagram of decoder and truth table. So after I will explain all these things, within 15 to 30 minutes, you will prepare a truth table and logic diagram in your book for encoder and decoder both. Take photo of it and paste in this given space. Next, same encoder, decoder. Procedure you need to type simulation result. Online will perform their practical on virtual kit. Offline students can perform their practical using kit. You can take off it and you need to sit it out. Conclusion, pre-lab and post-lab exercise. Is there any doubt in lab manual preparation? So start your work, take out your pen and book. First of all, decoder, truth table and circuit. Encoder, truth table and circuit. 2 cross 4, 4 cross 2. Once it will be prepared, collect your IC. Which IC you will require? 74. This is a ready IC. 74138 is ready-made IC. where you just need to give input and take the output. Today you need to design using AND gate. You need to design it. Whatever you are going to design today, a circuit of it is ready-made available. Decoder IC 74138. Internal of this IC you are going to design today. I hope you are getting my point. So start your work. Yes. Now you can leave the meet. Now online student also will take their book and pen outside. They will write the truth table, 2 cross 4 decoder, truth table, equation, and logic diagram. This should be prepared. This should be prepared in your book. Okay, once it is prepared, then you will open virtual kit. On virtual kit, you will implement two cross four decoder circuit using virtual kit. You need to verify the output of virtual kit with your book truth table. I have put all my words in the chat box so you can easily get my word. Okay, this is your task. Once this thing is done, and then you will be asked to share your screen. Once all this thing done, then you will prepare 4 cross 2 encoder. Encoder, truth table equation and logic diagram. Okay, so start your work. And if any point of time, if you will have any doubt, please let me know. Is there any query? Student, those are online. Okay, so you can start your work now.